Hey, very good morning, students. Let us see the next topic, construction of SR flip-flop using NAND gates. We have seen how to construct SR latch using NAND gates. Now we are going to see how to construct SR flip-flop using NAND gates. Okay, it is a very simple thing. It is six-step procedure. So first step is you need to draw the circuit diagram. Second is you need to write the working of SR flip-flop. Then rewrite the truth table. Draw the characteristic table, write the characteristic equation and execution table. Hardly 6 steps. Let us start with the first step, circuit diagram. So, SR flip-flop is an extension of SR latch. This is your S and R latch using NAND gates. There are two inputs, S input, R input is connected to NAND gates. Output of one is connected to the input of other. Output of one is connected to the input of other. So SR latch has two inputs, S input, R input. Outputs are Q and Q bar. Now this SR latch is used to construct SR flip-flop. This SR flip-flop has three inputs. Can you see this? S input, R input. Along with that, there is one more input called clock input. This one end of the clock is connected to S, other end is connected to R. So this is constructed using what gate? NAND gate. So I am connecting a NAND gate here. Output of this NAND gate is directly connected to S latch. Output of this NAND gate is directly connected to R latch. So now can you see how we have extended it? So through SR latch, we have designed a SR flip-flop. In SR latch, you have two inputs, S input, R input. Q is output, Q bar is output. Whereas SR flip-flop has three inputs, S, R and clock. This S, R and clock are connected to SR latch via these two NAND gates. One input of the NAND gate is S, other input is clock. One input of NAND gate is R, other input is clock. Okay. So there are three inputs, S, R, clock. Two outputs Q and Q bar. Now let us see the truth table of SR latch. You know the truth table of SR latch already we have seen in the last video. S star R star, output is Q and Q bar. When both are 0 0, invalid. Both are 1 1, it acts like a memory. If it is 0 1, you get inverse 1 0. If it is 1 0, you get inverse 0 1. This is what we have seen in the video of SR latch, right? How to get this truth table. Now what is that we are going to do is, we are just going to extend this and see the working of SR flip-flop. Let us see the working of SR flip-flop. So this is my SR circuit diagram. Just now we have did it. Now we are going to see how to get the working of SR flip-flop. So there are three inputs, clock, S, R. Clock, S, R. How many outputs? Two outputs, Q, Q bar. Q, Q bar. Let me take, if clock is 1, okay, S is 1 and R is 0. Okay, clock is 1, S is 1, R is 0. What will be the output Q and Q bar? Let us see this. Clock is 1, S is 1, 1 into 1 is 1, 1 complement is 0. My S star is 0. 1 into 0 is 0. 0's complement is 1. My R star is 1. When my S star is 0 and my R star is 1, what will be my Q and Q bar? 1 and 0. My Q will be 1, Q bar will be 0. Right? 1 and 0. So when S is 1, set is 1, you get output as 1, Q as 1. So I call it a set state. Okay, this is the first condition. Now let us see the second condition. See this condition. Clock is 1. Previously it was 1 0. Now it is 0 1. I make S as 0, R as 1. S as 0, R is 1. So let us see. 1 into 0, 0. 0 complement is 1. So S star is 1. 1 into 1, 1. 1 complement is 0. R star is 0. Now go to the truth table. S star is 1. S star is 1. R star is 0. R star is 0. What is the output? Q is 0. Q bar is 1. Q is 0. Q bar is 1. Write it 0 and 1. It means whenever reset is 1, you reset the circuit. So Q becomes 0. This is the inference. Now let us see the next state. If clock is 1, both S and R are 0, 0, 0. If both S is 0, R is 0, what happens? 1 into 0, 0, 0's complement is 1. 1 into 0, 0, 0 complement is 1. So S star and R star is 1, 1. When both are 1, 1, it acts like what? Memory. What is memory? When both are 1, 1, it acts like memory. It means whatever was there in the previous state. If 0, previously 0 is there, you get the same value 0. Previously 1 is there, you get the same value 1. Whatever was available in the previous state, that will remain same. So this will be 0 and 1. It means it acts like a memory. Now let us see the next one. What happens if S and R is 1, 1? We have seen all the cases 0, 0, 0, 1, 1, 0. Now we are seeing 1, 1. If S and R are 1, 1 and clock is 1, what happens? 1 into 1, 1, 1 complement is 0. 1 into 1, 1, 1 complement is 0. So S star and R star are 0, 0. When S star and R star are 0, 0, it is an invalid case. So I am writing all as invalid. This is the truth table of SR flip-flop. So you can write it as a working of SR flip-flop. When set is 1, can you see? When set is 1, I get output as 1. When set is 0, when reset is 1, I get output as 0. When S and R both are memory, both are 0, 0, it acts like a memory. When S and R are 1, it is invalid. This is what the truth table of SR. This is what we will write in the working of SR. What is the next thing? Rewrite the truth table. This is the truth table just we have written. What is the third step? Rewrite the truth table in terms of Qn and Qn plus 1. What is Qn? Previous state. What is Qn plus 1? Next state. If Qn plus 1 is next state, Qn is the previous state. You should understand this. Okay. So you have seen this truth table. Clock, S, R, Q, Q bar. I am writing it as Qn, Qn bar. Okay. So this is the truth table. Just now we have written it. From this we are going to write this truth table. What is this truth table? Rewrite the truth table in terms of Qn and Qn plus 1. So what are the inputs I should have? Clock, S and R. What is the next column? Next column should be Qn plus 1. So when S and R are 0, 0, see S and R are 0, 0. What is Qn? It acts like a memory. See this. When S and R are 0, 0, it acts like what? Memory. So whatever was there in the previously, you get the same thing. So you get what? Qn. Okay. When S and R are 0, 1, set is 0, reset is 1. What is it you get? Reset. Reset means 0. So write reset. When set is 1, reset is 0. You know it is set. Qn is 1. So you write 1 here. When both are 1, 1, it is invalid. So what is that we are deriving? It is very clear. 0, 0 means what? Memory. Memory means whatever was there in the previous value, you will get the same thing. So it is Qn. 0, 1. Reset is 1. So make reset 0. Set is 1. You get 1. When both are 1, 1, invalid. So have I written the truth table in terms of Q of n plus 1? Yes. Now from this table you need to get characteristic table. See the characteristic table. What are the inputs for characteristic table? Qn, S, R are the inputs of characteristic table. You need to write Q of n plus 1. Okay, since there are three inputs Qn, S, R, so how many combinations? 0, 0, 0, 0, 0, 1, 0, 1, 0. So from 0, 0 to 1, 1, you need to fill it. After filling it, you need to write Q of n plus 1. This how can you write it? This is written from this table. When Qn, can you see when S and R are 0, 0. See here, when S and R are 0, 0, what should be Q of n plus 1? What should be Q of n plus 1? Whatever value you have in Qn will come as such. Whatever value you have in Qn will come as such in Q of n plus 1. Is it clear? So, yes, when s and r are 0, 0, whatever value you had in Qn will come in Q of n plus 1. So, s and r are 0, 0. What value you have in Qn? 0. So, it will come as such in Q of n plus 1. Now, see the next one. S and r are 0, 1. When s and r are 0, 1, you get output Qn plus 1 is what? 0. When s and r are 0, 1, Qn plus 1 is 0. When s and r are 1, 0, if it is 1, 0, what is Qn plus 1? 1. So write 1 here. If s and r are 1, 1, what is Qn plus 1? Invalid. So write invalid here. Similarly, if s and r are 0, 0, what is it you get? The output, if s and r are 0, 0, you get Qn. What is there in Qn now? Qn is 1. So you write 1 here. If it is 0, 1, if it is 0, 1, what is that you get? You get 0. You get 0. If it is 1, 0, if it is 1, 0, you get 1. You get 1. If it is 1, 1, if it is 1, 1, you get what? Invalid. You write invalid. So from truth table you write next state table. From next state table you write characteristic table. Now from characteristic table, are we done with circuit diagram, working, rewriting truth table and characteristic table? Now from characteristic table, characteristic equation. It means I need to find the equation for Q of n plus 1, next state. So how many variables are at the input? Qn, S, R. So it is 3 variable K map. This is Qn. This one is SR. You know Qn 0, 1. Qn bar Qn. This is 0, 0, 0, 1. 1, 0 and 1, 1. Mark it. When Qn is 0, S is 0, R is 0. Qn is 0, S is 0, R is 0. What is the output? 0. When Qn is 0, S is 0, R is 1. Qn is 0, S is 0, R is 1. What is the output? 0. When Qn is 0, S is 1, R is 1. Qn is 0, S is 1, R is 1. It is invalid. Invalid means don't care. So fill the whole outputs of Q of n plus 1 in terms of truth table. Now do the grouping. How will I do the grouping? This 4 will form a quad. So this is my first group. This 2 will form a pair. If I fold like this, this is my second group. So what is common between this SR bar? So S is common. So S plus. What is common between this pair? Both belong to what? Qn. So I have written Qn. In the vertical, what is common? S bar, R bar. Here it is S, R bar. So R bar is common. So it is Qn, R bar. Okay. So this is the characteristic equation. So you derive this characteristic equation from characteristic table. Now you need to write the excitation table. Excitation table means you need to write previous state, you need to write present state. That will be the inputs. S and R will be the outputs. So since Qn and Qn plus 1, 2 inputs 0, 0, 0, 1, 1, 0, 1, 1. So when Qn is 0, Qn plus 1 is 0. When Qn and Qn plus 1 is 0, 0. Now see here Qn and Qn plus 1 is 0, 0. Can you see 1 and 2? 0, 0, 0, 0. Can you see Qn and Qn plus 1 are 0, 0. What is the value of S? Both are zeros. So S is 0. Whereas R is 0 and 1. It means it is not fixed. So it is don't care. It can be either 0 or 1. So I have written it as don't care. If Qn is 0, Qn plus 1 is 1. Qn is 0. Qn plus 1 is 1. Can you see the state? Qn is 0. Qn plus 1 is 1. Right? What is the S value? 1. What is the R value? 0. S value 1, R value is 0. If Qn is 1, Qn plus 1 is 0. Qn is 1. Qn plus 1 is 0. Can you see Qn plus 1 is 0? This place. Qn is 1. Qn plus 1 is 0. Qn is 1. Qn plus 1 is 0. What is S value? 0. R value is 1. 0, 1. When both are 1 ones, it means, can you see this place? Qn is 1, Qn plus 1 is 1. Even you have here Qn is 1, Qn plus 1 is 1. Here S is 0 and 1. It means it is don't care. Whereas R is 0 and 0. So I have written 0. Clear? Can you see this case? Here you have Qn 1. Here you have Qn 1. Here you have Qn plus 1 1. Qn plus 1 1. So 0 and 1. So it is don't care. 0 and 0 same. So it is 0. This is how you need to write the excitation table. If a SR flip-flop is asked, first draw the circuit diagram. From circuit diagram, truth table, working of SR flip-flop, rewrite the truth table in terms of Q of n plus 1. Write the characteristic table. From characteristic table, characteristic equation. From characteristic table, write the excitation table. So in truth table, you have S and R inputs, Qn bar is the output. In rewriting truth table in terms of previous states, S and R are the inputs. Instead of Qn, you write Q of n plus 1. Whereas characteristic table, what are the inputs? Qn, S, R are the inputs. You will derive Q of n plus 1. From this, you have to write the characteristic equation. You know what is excitation table. If my outputs Qn and Qn plus 1 is 0, 0, 0, 1, 1, 0, 1, 1, I need to write what is my S and what is my R. So this is the functioning and working of